In this video, we'll talk about the measures of location in which we have the following topics: the mean, median, mode, and the geometric mean. The most commonly used measure of location is the mean. Fourth, this is the average value for a variable. This mean provides a measure of central location for the data. If the data are for a sample, then the mean is denoted by x bar. Okay, something like this. The sample mean is a point estimate of the population mean for the variable of interest. If the data for the entire population are available, the population mean is computed by the same manner but denoted by the Greek letter U, or this is for the mean. So, in statistical formulas, it is customary to denote the value of the variable x for the first observation by x sub 1, and the value of variable x for the second observation by x sub 2, and so on. So in general, the value of variable x for the ith observation is denoted by x sub I. For a sample with n observations, the formula for the sample mean is given. Okay. X bar, which is to get the sample mean, is equal to the summation of x sub I over n. So that's for the summation of x sub I, that's equals to x sub 1 plus x sub 2 up to the x sub n divided by n. And n is the sample size. So here, the mean can be found in Excel using the average function. This figure shows the home sales data in Excel spreadsheet, and the value for the mean in cell is calculated by the average formula from first, okay, first home sale up to the last home sale. So this is the illustration for the computation of the mean for home selling price for the sample of 12 home sales. So the formula is equal to the summation of x sub I divided by n. So here we have to add all the sales, okay, starting from the first observation up to the last divided by 12. That is equals to 219,937.50. And now, so the median, this is the value in which the another measure of central location. So this is the value in the middle when the data are arranged in ascending order. Ascending order, that is from smallest to the largest value. With an odd number of observations, the median is the middle value. An even number of observations has no single middle value. So in this case, we follow the convention and define the median as the average of the values for the middle two observations. Now, let us apply this definition to compute the median class size for a sample of 5 college classes. So we have here the 5 college classes, and we have to arrange the class size data in ascending order. And the middlemost value in the data set is 46. So since we have um, 5 college classes, so the middle of which is 46. So the median is 46. Now, um, for the even number of observations, like given this data, first we have to arrange the data in ascending order. And now there are 6 observations. So the average of 2 middle values is we have here. Okay, I'm sorry. This is not 6 observation, but 12 observations. So the 1, 2, 3, 4, 5, 6. The 6th observation and the 7th observations are the 2 middle values. So we have to get the average of these 2 values, and we have our mean of 203,750. Now for the measures of location, um, this is the third mode or the third measure of location. So the um, value that occurs most frequently in a data set. So that is how will you get the mode. So to illustrate the identification of the mode, consider the sample of 5 class sizes. We have 32, 42, 46, 46, and 54. As what you have observed, 46 is the only value that occurs more than once. So the mode for this class size data is 46. So it appears twice in the data set. Now, there is what we call the multimodal data. Um, Occasionally, the greatest frequency occurs at 2 or more different values in which case more than one mode exists. So if data contain at least 2 modes, we say that they are multimodal. And in a special case of multimodal, data occurs when the data contain exactly 2 modes. In such cases, we say that the data are bimodal. So this is the figure that shows calculating the mean, median, and mode for the home sales using the Excel. Now for the demonstration, we will go to the Excel data. So in which here we will put the mean, median, mode 1, and mode 2. Now for the mean, we will have the formula, okay, average in Excel, and we have the range of cells from B2 to B13. Then enter. Then for the median equals median. Then from B2 up to B13. Enter. Now for mode 1 and mode 2, we have 2 options here. Single and multimodal. Okay. So for mode 1 and mode 2, we'll be using the control shift enter for this. And since we have 2 modes here, because there are 2 values that appearing twice, we have 138,000 and 154,000. We have to select E4 and E5 for our mode 1 and mode 2. Then equals mode dot malt. We have other option, um, uh, mode dot single that returns the most frequently occurring or repetitive value in an array or a range of data. Now for mode dot malt that returns a vertical array of the most frequently occurring or repetitive values in an array or range of data. Take note, for the horizontal array, we have to use the transpose function. And inside the transpose function, we have to call the function mode.molt. So we have to use this one, mode.molt. Then the range of cells from B2 up to B13. Then press the key combinations, Control, Shift, Enter. So now we have the values 138,000 and 254,000. Thus we have two modes here. Okay, thank you. Now the geometric mean, this measures the location that is calculated by finding the nth root of the product of n values. So this will be used in analyzing growth rates in financial data. So to calculate the sample geometric mean, we have the formula that is x bar sub g is equal to the nth root of x sub 1 up to the x sub n. So that is, we have the data for the annual percentage or the percentage annual returns and growth factors for the mutual fund, which is shown here. Okay. And growth factors for the mutual fund data over the past 10 years. So we will determine the mean rate of growth for the fund over the 10-year period. So we have the 10-year period in which the first year has a return percentage of negative 22.1%. Then, so this table shows the data for the annual return and growth factors of the mutual fund. Now, the first year has a growth factor of 0.779. Okay, so as a solution, the product of the growth factor is equal to $100 multiplied by the growth factors of the 10 data or for 10 years. That's equal to 133.45. And the geometric mean of the growth factors, you can get this one by having this manual computation. And we can conclude that annual returns grew at an average annual rate of 1.029 minus 1 times 100%, or this equals to 2.9%. So for calculating the geometric mean for the mutual fund data using Excel, we will be using the geo mean. So the geo mean, that's equals to, I have calculated already this one. So equals the geo mean, okay, then the growth factor from C2 up to C11, then enter. So we have 1.029. Okay.